Hi, Algebra 2 Trig. We're doing the last section of Chapter 3, and we're going to be dealing with slant asymptotes. The essential question is what happens when the degree of the rational function is higher on the numerator? And go ahead and write that down. We'll do an example. Okay, so my example is f of x equals x cubed over 2x squared minus 8. Okay, so all the problems we have been doing in class so far, the degree's always been either equal or smaller on the top. Okay, we've never done one where it's bigger on the top, so we want to talk about that because when it's bigger on the top, if you remember from your notes before, we don't have a horizontal asymptote. So what we have now is a slant asymptote. So this is what we're going to do. We're going to write down, we're going to go ahead and draw our graph. Okay, and then let's label all the stuff that we can label before. Okay, so the y-intercept, well, number one, let's simplify it. So I have x cubed, and the bottom will factor into 2 times x plus 2, x minus 2. If you have any questions about factoring, there's a factoring section somewhere in the P chapter. Okay? All right, so let's plug stuff in. So y-intercept, I know my y-intercept is when x equals 0. Okay, so I'm going to plug in 0 on the top. And then if I have a 0 on the top, 0 over anything is 0. So therefore, my y-intercept is 0, 0. My x-intercept is when y is 0. So I'm going to do this off to the side. My f of x is y, so I'm going to replace that with 0. So 0 equals x cubed over 2x squared minus 8. I'm going to multiply both sides by 2x squared minus 8. And I will end up with x equal, it's actually x cubed equals 0. And then when I cube root that, it will be x equals 0. So when my y is 0, my x is also 0. So my x-intercept is 0, 0. Okay, there was nothing to cross out, so I'm going to say there was none. And now, typically we would write horizontal asymptote. Right now I'm going to write SA for slant asymptote. Okay, so the way we find a slant asymptote is we are actually going to long divide this. So we are going to long divide 2x. I'm going to divide x cubed by 2x squared minus 8. So the x cubed. Now, I know I have no other degrees, so I got to add all the missing degrees. It would be 0x squared plus 0x plus 0. Okay, so now I need this to turn into x cubed, so I'm going to multiply that by 1/2 x. So 1/2 x times that is x cubed. 1/2 x times negative 8 is negative 4x. It's negative 4x. I'm not going to put it under the x squared. I got to put it under the like term. So I'm going to put that under negative 4x. Draw a line. Remember, I subtracted, so I'm going to change the sign. This is 0. This is 0. And then 4x plus 0. Okay. So now that I look, I can't really multiply anything by x squared to get 4x. So if I know 4x is my remainder. So it'll be 4x over 2x squared minus 8. Okay, so whatever is not the remainder, I repeat, whatever is not the remainder is the slant asymptote. So this is my slant asymptote. The slant asymptote is y equals 1/2 x. And again, if I had another term other than remainder, that would also be part of it. So right now my slant asymptote is 1/2 x. My vertical asymptote is what makes my denominator equal 0. So I'm going to look here, and x, when it's negative 2 or 2, it's going to equal 0. So x equals plus or minus 2. And then I'm going to leave some room for additional points in case I need it. I don't know if I need it just yet. Probably will know. Okay, so x and y. All right, so let's start drawing anything we can. I know my x and y intercept are 0, 0. I know I have a vertical asymptote at 1 and 2. 2 and negative 2. So I'll probably have 3 parts of a graph. And then I have a slant asymptote at y equals 1/2 x. So that's a line with a slope of 1/2. So I'm going to go rise 1 and go over 2. So rise 1, go. So I have another slant asymptote. That goes through there. Okay? All right, and keep in mind, I don't want you to freak out that there's a 0, 0 on the slant asymptote. Just like horizontal asymptotes, my graph can go through a slant asymptote. Okay? All right, so my extra points, I'm probably going to graph 1 just to see where it goes. Okay? I want to graph after that point, so I'm going to graph 3. And then I want to graph before that point, I'm going to graph -3, and then we'll go from there. Okay, so if I plug in 1, I will get 1 over 2 minus 8. So it would be -1/6. So it would be 1, -1/6. So it's somewhere here. And I can kind of guess if I plug in -1, it'll be +1/6. So between here and here, I already know it goes down and towards the vertical asymptote, and I know it goes up and towards the vertical asymptote. Okay? All right, let's graph 3. So if I graph 3, I will have I'll have 27 over, this will be 9. 9 times 2, 3 squared is 9. 9 times 2 is 18. 18 minus 8 is 10. So it'll be 27 over 10, which is roughly 2.7. If I plug in -3, it'll be the same thing, except it'll be opposite of that. So it'll be -27 over 10. Okay, so let's graph those points. It'll be 3, 22.7 roughly. Okay, so it'll be 3, 2.7, so somewhere here. And then it'll be -3, -2.7. So 1, 2, somewhere around here. All right. So, normally I would graph maybe one more point to see, but I already know these are asymptotes, so I can kind of guess that this graph is going to go down towards this asymptote and then left towards the slant asymptote and never quite reach. Same thing here. I'm going to go towards the slant asymptote, never quite reach, and then since there's a vertical asymptote here, I'm going to go up and towards the asymptote. Okay? So I think you've graphed enough of rational functions to know that your graphs go towards the asymptote, so you don't have to graph as many points as you did in the very beginning. If you have any questions, write it down and we'll talk about it on Monday.